In Lesson 34, we begin trigonometry with an introduction to angles and to degree and radian measure of angles. This lesson is from Section 1.1 in Version 2 of the Trigonometry textbook. In an introduction to angles, we begin with a ray. A ray can be thought of as half of a line. It contains one endpoint and all points to one side of that endpoint. Two rays that share a common endpoint result in an angle. The common endpoint is referred to as the vertex. The measure of an angle is the amount of circular rotation about the vertex that is required to move from one ray to the other. Here we can see that there is some ambiguity since there are two different measures identified by this definition. In thinking of angle measure as the amount of circular rotation about the vertex, we first measure angles as the proportion of one revolution required to rotate from one ray to the other. Here we have one full revolution where the two rays end up pointing in the same direction. The angle resulting from half of a revolution is referred to as a straight angle, and then 1/4 of a revolution results in a right angle, commonly noted graphically with a small square appearing at the vertex between the two rays. In degree measure of angles, which you are likely most familiar with, one revolution is equivalent to 360 degrees. Half of a revolution, determined by multiplying 360 degrees by 1/2, is 180 degrees. And then 1/4 of a revolution is 1/4 of 360 degrees, or 90 degrees. For some terminology regarding angle size that we will refer to frequently throughout this course, an acute angles measure is between 0 and 90 degrees. A reflex angle is between 180 degrees and 360 degrees. An obtuse angle measures between 90 degrees and 180 degrees. Then finally, we include the angle measuring 0 degrees in which the two rays are identical. Next, we will look at radian measure of angles. This will be the measure we use most frequently in trigonometry and later in calculus. Before we define a radian, note that we have a central angle in this sketch. A central angle is an angle with its vertex at the center of a circle. The central angle here is alpha. The angle alpha is subtended by an arc of length r, where r is the radius of the circle. By definition, alpha has radian measure 1. Note that we may refer to the angle as alpha or to the measure of the angle as alpha. So we might say alpha has measure of 1 radian, or we might say alpha is equal to 1 radian. In radian measure of angles, one revolution is 2 pi radians. Noting that pi is approximately 3.14, there are approximately 6.28 radians in one revolution. If I just try to sketch those here. So about 6.28 radians in one revolution. We will shortly learn to convert between degree and radian measure, but for now just note that 1 radian, so this is 1 radian here, approximately. 1 radian is approximately equal to 57.3 degrees. Well then, for half of a revolution, the angle measure in radians is 1/2 times 2 pi, or pi radians. 1/4 of a revolution has measure 1/4 times 2 pi, or pi halves radians. Sometimes we include radians with the measure, sometimes we don't. We'll talk more about that later, but let's move on to supplementary angles for now. Supplementary angles are two angles whose measures add to 180 degrees or pi radians. They may be two right angles or one acute angle and one obtuse angle. To find a supplementary angle for 73 degrees, all we do is take 180 degrees minus 73 degrees, and that results in 107 degrees as our supplementary angle here. If we have an angle 2 pi over 3, to find the supplementary angle, we would take pi minus 2 pi over 3, which we could write as 3 pi thirds minus 2 pi thirds, and we can see that the resulting supplementary angle is pi thirds. Then complementary angles are two angles whose measures add to 90 degrees or pi halves radians. They must be acute angles in this case. To find a complementary angle for 73 degrees, we would take 90 degrees minus 73 degrees to give us 17 degrees. To find a complementary angle for pi sixths, we would take pi halves minus pi sixths. We would write pi halves as 3 pi over 6. 3 pi over 6 minus pi over 6 results in a complementary angle of 2 pi over 6. And of course, we'd want to simplify to write that as pi thirds. Try on your own number 1 for this lesson is to, first of all, find a supplementary angle for 122 degrees, and then to find a complementary angle for pi thirds.